Okay, guys, we are doing, guys, ready? 6-6, continuity and end behavior. This is really not hard, I promise. It's not bad. Do you guys have the title written down? Yeah, okay. So there are 3 different types of discontinuity. The first one is infinite. It looks like an asymptote. So I'll give you guys a minute to write here, and then I'll show you graphically what this would look like.
You remember that, right? Thank you.
I'm going to make a sketch of one of these just so you can see what's happening. So guys, discontinuity, it's related to your domain. Like if there's a value that x cannot equal, then you have discontinuity. So let's look at the first f of x there. I've got 2 over x plus 3. Is there something that x cannot equal here? What? -3. What that means is that you have an asymptote at x equals -3. Okay? Technically, that graph also has one at 0. And we could sketch our points, but the shape of it looks like this. So you guys see how that graph is not one continuous piece? Like if I wanted to trace that with my pencil, that you would start over here, you trace, and then you'd have to lift up your pencil to come over here and trace it. That means there's discontinuity. If you have to lift your pencil off the paper to keep tracing, you have a discontinuity. Okay? That's as simple as it is. It's really not bad. So the second f of x, guys, what could x not equal in that one? 2 and -2? Everyone gets that? We could factor that. So the way you would tell me that you have discontinuity, kind of like the max and the min, you'd tell me what it was and where it occurred. So like on the first one, you would say infinite at x equals -3. Over here, you'd say infinite at x equals plus or minus 2. No, because that's not infinite, that's infinity. So it can't be infinity at x equals. That's it, yeah. Not too bad, right? For infinite, that's the first of, see at the top how it says 3 types of discontinuity? We've done 1. All right, let's try number 2. Oh, gee. All right, guys, our second type is a whole. You guys be familiar with both names for this one. We can call it removable or we can call it a whole. And we'll look at both of these f of x's. So, Simi, your favorite factoring? So, okay. All right, guys, so let's look at the first f of x here. Can you factor that numerator for me? I was like, is that a no? Plus 6 minus 2, right? Okay. So we look at it and we see it's a fraction, so I know right away I will have an issue when x equals 2, right? We get that, okay? But do you see how the factors cancel? So we still have discontinuity at x equals 2, but it's not an asymptote anymore. Because it canceled, that is when we have removable or a whole at x equals 2. You guys see the difference between that and an asymptote? Sorry, I'm going to move it up a little for you. This one just has a whole. This one is like, if the factor cancels out, it's a whole. Yep. So the next one, let's factor. We've got to factor numerator and denominator. So factor that numerator. What does it become? And your denominator? She said it really fast, too.
Yes.
It's okay. Because all she's thinking about is what multiplies to give you 6 and adds up to 5. So you have those two numbers, you have a factor. Okay. In theory. All right, so look at your denominator. Right now, what can x not equal? -3 and 5, okay. One of those is a whole, one of those is an asymptote. So, what's left? Okay, I think yes. So, this cancels, so that means we have a whole at x equals -3. And then at 5, do you guys see how that's infinite? Or an asymptote? We get that? Okay. Question so far? Easy so far? Yeah, so if you graph, like, if I go back and graph this first one, after they cancel out, I'm just left with the line y equals x plus 6, so that's 1, 2, 3, 4, 5, 6. And then up 1 over 1, but the next one, so it's like a line, but there's literally like a hole in the middle of your line. Okay. All right, questions on holes? All right, one more type, okay? This one is called a jump. And you're usually going to see this in a piecewise function. You guys remember piecewise?
some days that we didn't get, and going to school and not getting paid for 12 days.
Wait, what?
You know how we're going to school 12 days?
I know. Yeah, I'm working for free for 12 days. That's what that means.
Yeah, what is this?
Mm-hmm.
They should give us a 2 weeks.
But you probably teaches you.
Yes, but not. There's like 3 different unions here.
What?
Yeah.
You're part of the math union. Positive, there's all I'm saying.
The math department does not have its own
Are
union.
you like basically? Are you like on like what you're in some ways? Are
Do you
you?
think people
It's supposed to be.
Wait, why? Why?
Sorry,
Like, you guys should
yeah.
definitely
Yes,
protest.
we'll go straight to you.
Why not?
Right, and we don't have to.
Thanks, guys.
No, but 12 days, it's not fair.
It's a lot of money to go. So, since we didn't use any snow days, that basically means, like, we're working for free for 12 days. Like, I'm not going to get paid, but I'll work 12 extra days. You know what I mean?
Or just tell me I'll take naps.
Just tell
Or
everyone.
actually, I like that. Or 2 weeks spring break.
Fridays after sports.
I've actually seen it.
That'd be beautiful. I like that.
Like just 2 weekends off on Friday, you go to the games, and then Saturday you're like doing whatever, and then Sunday it just sucks.
Oh.
Yeah.
On Sundays,
There's an actual thing going
so
around
sad.
Oh.
I couldn't go outside. I just
This is the first time I've seen that one, but I like it.
Yeah,
I have to take, I'm finishing up my master's degree and I have to do oral exams over spring break, so I would love another week of spring break.
What are you getting your master's in?
It's like math curriculum.
We're all going on strike.
I'm down.
But yeah, it's a little daunting for an hour and a half. They just ask me questions. Like,
An hour and a half?
yeah, that's what an oral exam is. Like, I stand there and there's a 3-member committee and they ask me questions over all the grad classes I've taken. Just for 90.
Wait, but did they ask you math questions? Or
Some are math, some are education. Yeah. I bet I can. Yeah, it's a little interesting.
Sounds boring.
I don't know.
Oh, that's just a bunch of different math symbols. We're talking about an integral, this is the summation, this is the limit. So it's not necessarily all one.
Oh, this sounds like a beautiful summer to me. I have so much soccer that I'm actually.
All right, now that we're all dreaming about a 2-week spring break, every Friday off, you ready for a jump? All right. So no, this isn't that bad. You can do this. So, guys, when you look at a graph of a piecewise function, it's very easy to tell from the graph if there's a jump. What I'm going to graph isn't either of these equations, but let's just pretend your piecewise looked like this.
Alright. Didn't hear about the strike.
Yes, we'll discuss.
You're gonna take this right here.
Oh dear. All right, guys. So, and I don't know why that little thing's showing there. Okay.
Yeah.
It's a little
I
more
don't get it.
complicated.
You should like what's the? I bet you guys it's just like a name now. Like, you need to actually. You should actually stuff.
You're always so All right, so looking at that graph, do you see how if I approach like where x is 2, do you see how you have to jump to get to the next section of the graph? So that's a jump. Okay, that's literally all it is. Graphically, it's super easy to see when it's happening. If I give you the piecewise equation, you don't have to graph it to figure out if there's a jump. You just check at that specific value whether or not there's a jump. So for the first f of x here, what you do is take this x value and plug it in. So I'm looking when x equals 2. So in the first equation, 2 plus 4, what is that? 6. Good work, guys. Okay. Then I plug it into the other one. So 2 times 2 minus 3, what is that? 1. Are 6 and 1 the same number? No, okay. That means you have a jump at x equals 2.
Wait, so it didn't mean anything that it was like greater than.
Nope, I know. Yeah, this one is not actually included, but that just means like if we were to sketch this, when x is 2, we'd have an open circle at 6 and a filled in circle at 1. So do you see how like one's aligned this way, one's aligned this way? Do you see how that creates a jump at x equals 2?
Okay.
Okay, that's all you're looking at. You're figuring out the open circle and the closed circle. Are they in different places or are they in the same spot? Okay. So let's try the other one. If I plug in a -1, -1 squared and then -2, what do I get? -1. 3 times -1 plus 2, what do I get? -1. Are those the same? So that means f of x is continuous. I'll show you graphically what it means.
It's really same, but what if they were just in a hole? Just both of them.
So if they were both, yeah, then you would have a hole there instead of a jump. Yeah, good question. What? It's actually a -1. Thanks. Yeah, because it's wherever this is. So guys, what this means graphically, if I went to do the first one where x is less than -1, when I plug in a -1, I get a -1, and that's an open circle. If I go to graph the second equation, when I plug in -1, I get -1, which fills in that circle. So that's why this one's like parabola, this one's a line. Do you see how it ends up being one connected graph? Okay. So with piecewise, I'm not going to make you graph them right now. Eventually we will. Okay, but right now you're just deciding, is it a jump or is it a continuous function? Okay. All right, so that's discontinuity. Are we okay with that? Okay. Now we're going to talk about end behavior of polynomials. So guys, I'll give you a second to jot this down and then we'll talk about what is happening. Do you guys know why I have those two parabolas drawn? I guess that's a no. What'd you say, Maggie? Sorry. door.
Oh, right here.
Yeah.
It always sounded really weird.
Some days it's propped open, and so you don't hear it, like people going in and out. But today it's not propped open, so every time someone goes in or out, we hear it.
I feel like it's your
That door.
I know, but it doesn't hear from
It's that door over there. We can like do an experiment with it if you want.
I do want to
I don't
do
know.
it.
Flushing would be over there.
Oh, wait, what did you say?
The door.
Oh,
I was talking about the
remember
door.
that noise I always told you I heard? It sounded like
Oh,
someone
okay.
breathing, like giving it a baby, but
That's just the plumbing.
it sounds so.
Is that what it is?
You hear that noise?
Yeah, only when
What? Yeah.
Only when it's really quiet and.
Yeah.
All right, guys, let's go through this. Okay, guys, this should be a review from Algebra 2. So if the exponent is even, and we're talking about the highest exponent of your polynomial, okay? If it's even, if it's 2, 4, or 6. When the leading coefficient is positive, this is what your graph looks like, regular old graph, okay? So as x approaches infinity, so that means as x is going really far to the right, where's your graph going? Up. What is way up there? Yeah, so as x approaches infinity, you can say f of x if you want. Oh, I need a pen. F of x approaches infinity. We'll get into limit notation with this later. Right now, you'll just tell me. You could even say y is approaching infinity. That's fine. What about as x approaches negative infinity? So as we go way to the left, where does your graph go? Infinity. Okay. All right, when your leading coefficient is negative on an even function, it just gets flipped over, right? So as x approaches infinity, where does y or your f of x go? You can have infinity. I don't know what you're pointing at. Oh, okay. It's like you're just pointing over there. All right, and as x goes to negative infinity, where does your graph go? Oh, I lost my negative. Okay. Easy. Yes, the other one is 1 up and 1 down.
So the exponent always has probability.
Now here we go. We can have, I'll erase those and make you think about it. We can have an odd exponent. Did you learn this as like touchdowns and disco or anything like that? No, like touchdowns, or like both up or negative both down, and then like the disco. Okay. You'd remember that, right?
Oh, Jesus. Were you like shocked at public school?
She's in my grade.
Oh, you didn't get it. Why'd you go to OGC? Really? How did you go to your class? And you didn't like it? So yeah, what am I reading? Weren't you like, it's like you left all your friends and then you came back tomorrow and you pulled mouths and everything?
I guess I was the one who's not in front.
You would say I mean to you. You're actually. It's so good, bro. You're never kidding. Oh, jeez. So don't be very cool.
So let's think about our graph here. Let's graph x cubed, which that's a parent graph you guys know, right? Yes, okay. You remember that was like beginning of this unit? This is a long unit, okay? So that is what your graph looks like when it's a leading coefficient that's positive. So as x approaches infinity, where does your function or your y value go? Yep, positive infinity. And as x approaches negative infinity, y approaches what? Negative infinity, good. So guys, negative leading coefficient. What happens to my graph? Yeah, it goes this way, okay? So as x approaches infinity, where does my graph go? My y values go? Okay, that was really quiet. Where does it go? Negative infinity. Okay, and then as x approaches negative infinity, where do your y values go? Positive infinity. Easy? Maybe. All right, anybody questions on this? Don't look. This is really slow. All right, guys. You can just do this on your whiteboard for me. So you need to just be telling me as x approaches infinity, y approaches what? As x approaches negative infinity, y approaches what? For each one of these. All right, guys, you do these four. I'm going to grab some more water.
Are you serious? I think you've asked me that before. I did. I'm really just happy. How do you know? A couple years ago. Well, it's right. I just. Yeah. Yeah. So it's very nice though from here. It's like oh my god, different. Just longboarding. Oh my god, wow. You're with him and he got that? Who is it, Rihanna? Rihanna? Wait, why did he say why? Did he not see?
No.
Did you get this stuff? Did they follow the... You get this? Did you say that so? No.
Everyone, I transferred them.
Oh, how are you doing, guys? What? What famous directors?
Oh no! Do we need to draw like some more stick figures? See if that helps. That was like too quick yesterday. That didn't work. What's your struggle? Okay. you to, oh dear. Okay. So, let's do steps. First decide, make like a flow chart for you. Is it even or is it odd? For the exponents. The biggest exponent.
So we got 2 on
The biggest exponent. We're looking at number 1. Biggest exponent. Okay, 3 is odd. All right, so we're going odd. Next step, decide. Positive or negative? Positive. Okay, right over here. This is the graph you think about this.
It's fine.
It's negative and going down.
Let's go.
He's buying into the flow chart. Okay. All right, so you're with me to this graph, right? Okay. I am asking you, as x approaches infinity, what do your y values do? So, as you trace your graph over here, so that is infinity, right? That direction. So as I trace the graph that way, where are my y values going? Okay. All right. As x approaches negative infinity. So that means this way, right? Where are my y values going? And what is way down? Okay. And that's number 1. All right, let's do number 2 together. Okay. Okay, so we'll start again. Number 2. Yeah. No, you only you could literally go. All right, no. That's all I need. That's all I need. All right. Well, let's do 2 together. Okay, so start back at the top. Even or odd? First question. Even. Okay, so we're over here. So then we go. Oh, I don't like that I changed colors. This thing's wrong. All right. So, positive or negative? Positive. Go over here. So we think about this graph. Okay. We're both going this time. Yes. So far we've gotten infinity, negative infinity, infinity, infinity. Yes? All right. Let's do 3 together. Start back at the top. Even or odd? Even. Okay. Positive or negative? Okay, so we're over here now. When it's negative, the graph you think about is that one.
So they're both negative, right?
Yes. Yeah? Okay. Last one, start at the top, even or odd? Positive or negative? Okay, so our graph now is that. So, what does that mean? As x approaches infinity, y approaches.
So x this way.
Yeah, where do your y right? Y. Okay, negative infinity. And as x approaches negative infinity, where do your y values go? Yes. All right. Woo! Baby steps. How's everyone else doing with these?
Not for the day.
We okay? All right.
So, please.
That you've already done. That we don't need. No, we don't need that. Do you want practice with discontinuity, or do you feel okay with it? Yeah. Let's do a little bit of practice here. You can just do this on whiteboards, though, guys. Don't look. I don't know why this is being so slow. Hurt your brain? I'm sorry. Oh, okay, so it's not just me.
No, it's not.
Well, that's good. Type and location of discontinuity. So that's back to infinite removable jump or asymptotal jump.
Wow, that's much worse.
This is so messy.
Sure, let's see. Yes, I'm ready. I had to look at what I even gave you as a problem because I forgot. Yes, I can read that. Yep. 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 Got it? Oh yeah, you don't ever have a... That's okay. It's that kind of day. Doesn't it feel like Friday too? And it's not. Yes. No.
Wait, what do you say?
I thought it was.
Yes. Yep, good. Yes and no. You have too many things there. Only one of those is right.
Or am I supposed to not write
Right. Where does that come from? Where did you even get a 3?
this? Wait, what? Oh wait, I wrote 2. Wait, so I don't write that in? Oh wait, just kidding.
Because that's not part of the denominator. Yeah.
Oh,
Okay.
my bad.
Good. Now you're... Yes. Do you see the difference? Okay.
Wait, what did I say?
Yes. Bobby, you got it? Okay. Good. Sandra, you good? Oh, sorry, Chuck. Okay. Yeah? Just yeah. You're not gonna show me anything. Just a yeah. You're gonna show me Bobby's board? Okay. Really close. Yes. Okay. I think everyone got there. I don't know, but I think. So it's a whole at x equals 1. You okay with that? Great. Try again.
That's so ugly though. I always wanted to name my kids
What do you want to name your kid?
that I can go like this. Basically, draw like my line, just like you want.
What is your middle name?
Right.
I should look at what I gave you as a problem.
Did you already know you were gonna name your kid before he was born?
No, we didn't decide until like 3 weeks before he was born. I was
3
like,
weeks?
yeah, we struggled.
No,
It's
that's
hard.
Like, they were like,
My mom,
like a couple weeks and we like didn't have
Yes.
names.
my mom made a giant group chat with her family and her friends, and they had a poll.
That's one of them. There should be 2 though. Okay.
What did they decide?
Yeah, we struggled with it. Good. Good. Because there'd be names, and I'm like, no, I had a kid one time in class.
Set on one name.
Well, and think about it. It's okay. This is my 15th year teaching, and I've had 150 students every year. Let's think about how many names that is.
Wait, did you have
It should be -4 instead of +4, but otherwise, yes.
Oh,
Good. Good. Yeah. Did you do just 1 or did you have 2? There should be 2. Oh. I can't really read that, so when I put it up there, just make sure it's right, okay? I think it's just your marker. Yes. Yes. Okay, let's look at this one. That's one of them. Guys, if there's more than one, make sure you write both. So I think everyone is okay with the factoring. The one that crosses out gives you a whole. The factor that is still left in your denominator, that gives you an asterisk. So you've got a whole at x equals -4, infinite at x equals -2. Okay?
oh my god. Literally used to have anxiety when I was little. It would be like this and they wouldn't switch that. I would switch.
Yeah.
To change. Oh, and that.
No, that's absolute value of x plus 2.
Oh,
Sorry. Yes. You do -2 plus 2 and then the absolute value of that. No. Yes. Did you get the same answer for both? Good. 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 Not for what I'm going to give you, yes, but in theory, you're right, there might not be. And then it's definitely discontinuous. You just have to decide, is it a jump or is it just a hole? Because then if they match, it would be a hole. That's what Jonathan was asking earlier. I can't see it when you hold it that way. Okay, that's the board is so you can show me without saying it, but yes. All right, guys. This one is a why at 1? What X value did you plug in?
Oh, never mind. I got it.
You see it? Okay.
Yeah.
All right, guys. So everybody okay with that one being a jump? Explain to me, why is it a jump? Yeah, you got different things, right? Okay. How many? I think this is our last one.
I completely agree, but that was when we had short Mondays. We're so great.
Yeah.
Elementary school. They don't do that anymore.
You guys can have it, right? Oh.
Kindergarten and half day every day.
Yes, kindergarten.
Yeah, we don't have that.
AM and PM. AM was so much better than that. That was always Monday.
Yeah, only the first 2 weeks.
AM and
You have too many things. Yes. Because that was a part of the numerator, right? So that doesn't cause us any discontinuity. Good, Megan. Good. Good. No. I think yes. All right, guys, let's look at it. Okay. When you factor it, 2 things cancel. Hey, Xander, make sure you're looking up here, okay? The x minus 3's cancel, right? You see that? That is where your hole is, but it's at what would make this 0. So what minus 3 is 0? 3. So that's why the hole's at positive 3. The factor that's left over, then that gives you your asymptote, your infinite x equals -3. Okay. Does that make sense, though, what we're doing? Okay. All right, guys. That's the end of. Let's do homework. No, homework. All right, guys. How about odds on the homework? And it's actually not hard, guys. Like, it's a pretty quick homework. If you do it now, you should be able to get it done. Okay, so I would highly recommend you do it now.